Okay, so good morning to everyone. So in previous class, we have discussed about that how from register the data is transmitted, and in the last discussion, we have seen that transfer from register, and in register transfer language, how it can be written. We have seen that here, if you see in this diagram, you will see that there is a single bus present, and in this bus the registers are connected, that R1, R2, R3, these three registers are connected to the bus. Now in RTL language, that means register transfer language, how it can be written. Let's say there is a problem that from R1, that R1 register wants to communicate with R2 register. This two register wants to communicate. That means R1 register will send the data to R2 register. Now in RTL language, how it can be written? Now, if you see in RTL language, it will be written like this, that from R1, the data is transmitted first to the bus. So from the position, from that particular position, the data is to be transmitted will be written in the right side. See, here I have written that R1 in the right side. And from where the data is, and from the position where the data is to be transmitted, that is to be written in the left side. You see that a arrow is given. This is the arrow, and from this arrow it suggests that from R1 register, from R1, inside the R1 register, the data that is present, that data is transmitted to the bus first. So that means from R1 the data will be transmitted to the bus, and from bus the data will be transmitted to R2. That means if R1 and R2 register wants to communicate, then this process will be like this. So from bus, you see, from next in the step 2, we have written that bus, because the data is now transmitted to the bus. So from bus, the data will be transmitted to the R2 register. So if R1 and R2 register wants to communicate, then it can be written like this in bus transfer. In RTL register transfer language, we write like this, that from the position the data is transmitted will be written in the right side, and the position where the data will be transmitted, that should be written in the left side. So like this, and here I have said that from R1 to R2 register, the data is to be transmitted. So like this, in the register transfer language, it is written like this: from R1 the data is transmitted to the bus first, and from bus the data is transmitted to the R2. So in register transfer language, we will write like this. Now we will move that. We have already seen that this is like this, that from register to register, if a register wants to communicate with another register, then the data will be transmitted to the bus first, and then from bus the data will go to the destination register. We have seen, but there is an internal circuit present, that in the how which register will be chosen and how it will work, there is an internal circuit present. So the internal circuit we will see now. So this is the internal circuit. This is the internal circuit. You see, this is the internal circuit present. Now let's say we have 4 register present. We have 4 register present in our explaining, that there are 4 register present. That is register A, register B, register C, and register D. And this 4 register has 4 output. This 4 registers has 4 output line. You see 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. That means this registers has 4 output line. Okay, so this is A0 because this is the register A. So we are considering it as A0, then A1, A2. Okay, and this is, we are considering as the A3. This is considering this is as the A3. Same as that for this also, it is B0, B1, B2, B3. Same as that for here also for register C, it is C0, C1, C2, C3, because 4 output are present. Same as that for register D also, this is D0, D1, D2 and D4. Okay, so now these registers are connected with the multiplexer. Now you all know that multiplexer means what? There will be 4 cross 1 or 8 cross 1. That means multiple inputs, but output will be 1. The multiplexer suggests that in digital electronics you have already know that multiplexer means there will be several input, but the output will be single. The output will be single. So there are 4 multiplexer present. Now we are considering this 4 multiplexer as a, we are taking 4 cross 1 multiplexer. That means there will be 4 input and only 1 output. There will be 4 input and only 1 output. Now you see A3, there will be like A0. So this multiplexer input will be like this, that A0, this is connected, then B0, this is connected with, then C0, this is connected here, and D0, this is connected here. So this, like this, there will be the 4 input present. So A0 is connected, then B0 is connected in this multiplexer, then C0 is connected in this multiplexer, and D0 is also connected with this multiplexer. So the 4 input of this multiplexer, the 4 input will be like this, and the output, then the output will be chosen as the, if this output will be chosen, and there will be 1 output. So which output we will say, but now you only know that this is 1 output will be chosen from this. Same as that for in this case also, in this multiplexer, there will be A1 will be 1 input, then B1 will be 1 input, then C1 will be 1 input, and D1 will be the another input. So for this multiplexer, the input will be A1, B1, C1 and D1. For this multiplexer, for this case of multiplexer, the input will be what? The input will be A2, the A2 will be the input, then B2 will be this input, then C2 will be this input, and D2 will be this input. So for this multiplexer, the input will be like this: A2, B2, C2 and D2. And for in this case, for this multiplexer, what will be the input? The input will be A3, B3, C3 and D3. So like this, all the multiplexer has the input, and all the multiplexer you see, all the multiplexer has the input combination, that you see all the registers combinations are present. That means A0 is of register A, B0 is for register B, C0 is for register C, and D0 is for register D. Means all combinations of inputs are present for this multiplexer. In this case, it will be A1, B1, C1 and D1. In this case, it will be A2, B2, C2 and D2. And for this multiplexer, it will be A3, B3, C3 and D3. That combinations of inputs are present in these registers. Now we have two selections. We have two selections lines. One is S0 and S1. Sorry, S1, and another one is S0. These two selections line present. Now, if S1 is 0 and S0 is also 0, S1 is 0 and S0 is also 0, then the register A will be selected. The registers A will be selected. That means our inputs combinations will be like this. If register A will be selected, that means register A will select means what? A0, A1, A2, A3. So that means from here, the A3 will go here. Then from this multiplexer, A2 will go here. Then from this multiplexer, A1 will go here. And from this multiplexer, A0 will be go here. If this is 0 and 0, selections line S1 is 0 and S0 is also 0. But if it is 0, 1, if it is 0, 1, that means from this multiplexer, what output will be chosen? The output will be chosen as B0, B1, B2, B3. So if it is 0 and 1, then register B is selected. That means the output will be B0, B1, B2, B3, B4. Now, in case of if register C is selected, if register C is selected, when it will be 1 0, when it will be 1 0, then register C will be selected. That means what will be the output? Then what will be the output? Anyone? What will be the output if 1 0 will be selected? Anyone can try?
A2, sir.
No. If 1 0 is selected, that means what? Register C will be selected. If 1 0 is there, then register C will be selected. So that means what output will be chosen? C0, C1, C2, C3. This will be selected. And if it is 1 1, if it is 1 1, then the which will be selected? The register D will be selected, and the output will be from this multiplexer D3, D2, then B3, D3, C3, B3, and from here this will be selected. So that means what? The combinations will be selected like this. So that means D0 from here, D0 will be selected from here, D1 will be selected from here, our D3 will be selected, D2 will be selected, and from here it will be selected D3. So this is the total circuit. This is the circuit that we are only saying that from this bus, the bus, that particular register is selected, but this is the circuit and this property is followed. So within this property, the particular register, which register will be chosen, we consider it from this circuit. Okay, it is clear to everyone?
Yes, sir.
समझ में आया सबको?
Yes, sir.
Okay. So this is the total transfer from register to the bus and computer bus system. Bus system where present bus system uses the multiplexer. Here we have selected 4 register, but if you want, you can select 8 register also. If this will be 8 register, that means there will be 8 cross, and we have to use then 8 cross multiplexer. Here we have selected 4 registers, and have 4 registers have 4 bits. But if we have selected the 8 cross 1, it may possible, or it may happen that if you choose 8 cross 1 multiplexer, if 8 cross 1 multiplexer, that means 8 input should be there. So that means 8 registers should be present, and 8 register will be the 8 bits present. Then like this, if we choose, then 8 cross 1 will also be, and if you choose 16 cross 1, then also, then in that case 16 input will be present. That means we have to use the 16 register, we have to use the 16 register, and for each register it will be 16 bits. In that case it will be the 16 bits. So like this, the transfer from register to bus and computer bus system using the multiplexer can happen like this. Okay, so this is all about the bus transfer. So now we are already uses the bus transfer. So like this, the particular register, which register bus will use what? Bus will use the decoder. The bus will use the decoder, and then transfer the information to the corresponding register. So it will transfer to the corresponding register. The data will be transferred to the corresponding register. That means like this, the bus will get, and in bus it will, a decoder will be present. So then this will be transferred the information to the corresponding register, in that which register it wants to communicate. In that particular corresponding register, the data will be transmitted. So this is all about the transfer from register to bus. But means bus transfer operation is like that. Now there is another transfer that is also present, that is the memory transfer. So how memory transfer works? Now, if you remember in previous class, I have said that we have four types of operations, that memory read, memory write, IO read, IO write. These are the four operations. Now, in memory transfer, if the name suggests that here memory transfer means the memory is involved here. Memory transfer means the memory is involved in here. So that means only two operations will be present among them. Among these four operations, only two operations will be there, because here the memory is involved. So that means memory read and memory write, this will be present. This will be present because here the name suggests memory transfer. That means all the operations that are happening will be in case of memory. So that means what? Only among these four operations, memory read and memory write are performed here. So memory read means what? Now, if memory read, we will see that what is memory read. Now, if let's say here that if from register, this is the register, and from register, in this register the data is stored. Let's say in a register the so the data is stored in the register, and this data is transferred to the memory. That means the data that is stored in the register will be transferred into the memory. The data that is stored in the register will be transferred into the memory. So transferred into the memory means what? The data is going to the memory. That means the data is written in the memory. So operations we call as the memory write. This operation we call as the memory write, because the data that is present in the register is transferred to the memory. The data that is present in the register is transferred to the memory. That means the data is storing into the memory. That means, or we can say that the data is what? We are writing the data into the memory. So writing the data into the memory means what? It means that we are writing into the memory. That means it is the write operation, or simple words we can say it is the write operation. And memory read is what? Just the opposite. Memory read means what? Just the opposite, that the data that is stored into the memory, we are storing that particular data. We are transferring that particular data into the register. We are transferring that particular data into the register. That means the data that is stored into the memory is transferred to the register. So that means it is what happening? It is memory read operation. That means data is read from the memory and it is storing into the register. So this is, if like this will be the memory read operation. So if you didn't remember, only use this portion, then you will remember and you will explain that what is memory read and what is memory write. If you doesn't remember the definition, then there is no problem. Only do what? Only if you draw this diagram, then it will came to your mind first that If the data is transferred from register to the memory, that means memory write. And if the data is transferred from memory to register, that means what? That means memory read operation. So this is memory write and this is memory read operations. Now, the transfer, let's say in good words, we can say that the transfer of information from memory word to the outside environment. Now here the outside environment, we said for this outside environment means the register. The outside environment means the register. That means the information from a memory word to the outside environment, or we can say it is a register, is called the read operation. That means the information or the data, whatever is present, is transferred from memory to register, from memory to register. And in case of write operation, in case of write operation, the transfer of new information is stored into the memory. That means from register, the transfer of information or the data into the memory, the write operation. So this is the definition we have already know. But how this read operation and write operation particularly works, that read operation and write operation particularly works, we will see that. Now, let a memory unit is present. This memory unit receives the address from the register, receives the address. Now, we have all said that the address is present. Now, this address, if receives the address from the register, then it is called the address register. Now, if you see that the data is transferred to the another register called the data register. Now we will go inside that. In register, I will explain that there are many types of register present in a system. Now, broadly, they are divided into two types. These two types are what? One is general purpose register and another one is the special purpose register. These two types register, broadly we divided that. Now, what is the difference between the special type of register and the general purpose register? Now, special purpose register is what? In register, it is capable of storing the address and the data simultaneously. It is capable. But special type of register, in special type of register, some registers are present. In that register, in among them that register, some register can store the data, some register can store the address, like this. That some registers, it can store the data and some register can store the address, like this. But the register that is present in the general purpose register, this general purpose register can store the both simultaneously, data and address. But in case of special purpose register, the number of registers are present, but some registers store data, some registers store address. Both cannot be simultaneously stored by the special purpose registers. But in case of general purpose register, in general purpose register, the registers are present, can store the data and the address simultaneously. Two types. Now, this memory unit receives the address from the register, and this register we call as the address register. This is the special purpose register because this memory address register, or we can say address register, is capable only storing the address, that means it is on the our address or on the special purpose register, because we have said that in special purpose register, among the special purpose register, there is what? There is some register can store the data, some register can store only address. In between this address register, or we can say memory address register, is only capable of storing the address. That's why it is among the our special purpose register. So this memory unit receives the address from the register called the memory address register, and the data is transferred to the another register. The data is transferred to the another register. The data will be present, will be transferred to the another register that is called the. Now this data register is only capable of storing the data, and it is also among a special type of register because it is only capable of storing the data, and this memory address register is only capable of storing the address. So both these registers are among the special type of registers. Now, what really happens? We said directly that from memory the data is transferred to the register, but which register the data is transmitted, we didn't say that till now. Now, what from memory the data that is present in the memory is transferred to the memory data register. Memory data register, we all know that the data is transferred to the register, but which register the data is transmitted? Now from memory, if the data is transmitted to the memory data register, the data is transmitted to the memory data register, and what operation is performed? The data that is the data that is present in the memory will be fetched from the memory and stored it into the memory data register. The data fetched from the memory and it is stored into the memory data register, or we can say that name is the memory buffer register, or we can say it as the memory buffer register. Now, read operations, if we say that the read operations can be stated as that from there will be, this is the, let's say with diagram, there is the memory, and in this memory this address register holds the address of a particular location. This here is the address register. This address register is doing what? It is holding a particular address into the memory, and in this particular address, let's say a data is stored. Let's say a data is stored, that is, let's say that is 10. So this 10 data is stored into a particular address of the memory. So what it is doing in that particular address, that in the memory address register, that means this address register is holding what? This address register is holding a particular address it is holding. So this particular address, and this particular address the data is stored, will be moved to the data register. So read operation basically performs like in the memory a particular location that is the address of that memory. In that address will be held by the address register, and the data that is stored in there will be go to where? The data will be go to the data register. In this particular location the data is present, will be go to the data register. Okay, it is clear? It is clear to everyone?
Yes, sir.
Anyone? It is clear? समझ में आया सबको?
Yes, sir.
Yes, sir.
Okay. So now, then write operation. Write operation is just, if we say that write operation is what? It will do that from register, the register that is stored in the data that is stored into the register will move to the memory first, and from memory it will go to the particular location. Is this address register is holding the particular address, so the data that is stored into the register will go to the memory first, and from memory in the memory there is address register is present which is holding that particular location. So in that particular location the data will be transferred. This is the write operation. That is said that if you the data stored in a register is stored into the new now address register of memory, it will be stored into the address register of memory, and from this address register we can understand the location of the memory in which the data of R1 register is transferred. So this is the write operation performs. Now, the transfer information from R1 in the memory word selected by the address in the address register. Now, let each register that consists of n bits data and RAM contents are equal to 2 to the power k words. That means now we will see that how the internal circuit, like the previous bus transfer also, we have seen the internal circuit. Same as that for memory transfer also, the internal circuits is present. Now, what is the internal circuit? Like this, the internal circuit looks like. Now, this is the our total internal circuit. That means this is the memory unit, that is RAM unit. You see, in this unit, n input lines will be present. In this RAM unit, the n data input lines is present. That means the input will be n data input lines. So if the n input data lines is present, that means output will be what? The output will be n data output lines, because if it is n input, then the output will be n. So that's why you see n data input lines and n data output lines, because if it is n input, then output will be n output lines. And there is an address line present. This address line is what? K address line present. Now, why K? You see here, we have said that R equal to 2 to the power K words. Now, K words means what? K words means this K is specifying the address line. K is specifying the number of address line. So, K address line will go here. And we already know that two operations are performed in the memory unit, that is read and write. So one read and one write operations are present. So it can also be broadly defined as like that from address register, the address is transferred from address register, the address is transferred to the memory unit, and in the memory unit we perform two operations, read and write. That means if we perform read operations, that means data is out. If we perform read operations, that means data is out. And if we perform write operation, that means we are writing the data into the memory. So that means it is data in. So this is like this. This is the internal circuit of the memory transfer. So memory transfer is performed like this. So we have already seen the memory bus transfer and the memory transfer. Okay, so now in the next class we'll explain the purpose of register, general purpose registers, that what are the registers and what are that perform. But today I will show you that what are the how the traditional bus system, works like here, the traditional bus system. So a traditional bus system, if you see, the traditional bus system looks like this. Now, a traditional bus system. So if a traditional bus system, it is looks like this traditional bus system. Here will be the processor present in traditional bus system. We have already said that the major components are present, are connected with the system bus. So here also you see that the processor is present and cache. Now you already know that what is cache. Cache memory is what? Cache memory is the fastest memory. Like register also, register is the most fastest. Register is most fastest, and cache memory is what? Cache memory it is the fastest memory. And in like this here, it is not its storage capacity is not much, but the particular data which we have to want to access immediately, we stored it into the cache memory. This is the cache memory is working. Now processor is doing what? Processor is connected with this cache, because if a processor is connected with the secondary memory or the main memory, then a particular thing which we have to search, it will take much more time. But if the data is stored into the cache storage capacity is not very much. So that means the particular data which want to access immediately, we store it into only into the cache. So that means this processor will do what? This processor will be connected with the cache. So, and it is connected with the local bus. You see, the processor is connected with the cache memory through a local bus. Now, local bus is what? This local bus consists of all the buses. That means what are the three types of buses present here? Our three types of bus present are the data bus, control bus, and address bus. This local bus consists of all the buses. Inside this local bus, it consists of all the bus, data bus, control bus, and address bus. And the processor is connected with the cache. Now, this total, we can say this is the CPU. So in the CPU, what? In the CPU, the processor is connected with the cache with the help of local bus. And here it is connected with local IO controller. It is connected with the local input output controller. And the main memory that is present is connected with this cache with the help of the system bus. With the help of the system bus, the main memory is what? The main memory is connected with the cache memory. The main memory is connected with the cache memory with the help of the system bus. And this system bus is connected if there is input output devices present through this explanation bus interface. It is connected. That is, you see network, modem, all these input output devices are connected with the help of the explanation bus. And all this bus, local bus, system bus, explanation bus, consist of the data lines. That means it consists of local bus, consists of address bus, data bus, and the control bus. Okay, so this is how the traditional bus system looks like. Okay, clear to everyone?
Yes, sir.
Yes, sir.